Welcome to Taxonomy Online Mathematics. We are still continuing with the tutorial on plane geometry 1. We want to take the aspect that is the Pythagoras Theorem. Now, Pythagoras Theorem was is developed from a right angle triangle, or is developed with the right angle triangle. It is one of the theorems that is used keenly in engineering. Basically, if you want to construct staircase, bridges, even the plumbers use this to be able to lay pipe so that the drainage can easily flow. If they are laying pipe to lay out or to let water to flow out, they use these Pythagoras theorems in order to allow to get the slope that they are trying to get, even in roofing, in order to be able to have a roofing that when it rains, the rain will easily drain out, not to have accumulation anywhere for it to fall in a room. We use the idea of Pythagoras theorem, which is basically this is a right angle triangle. We are going to play a square unit on each of the sides. So if we are measuring this to be 4 units, then we want to measure this to be 3 units, then measure this to be 5 units. So it means that per your ruler, you are going to measure 4 units. Now, since we are saying it's a square unit of each of the sides, so this is 3 square units, meaning 3 centimeter or 3 meter, 3, 3, 3. If it is 5 meter, it is 5, 5, 5. It's a square. Then 4. Now, we want to find out the area occupied by this. The area occupied by this is going to be, it's a unit of 1. So, 1, 1, we count all of them, and that is going to be 25. So that will give us 25 square units if I'm finding the area. Here also, if I'm counting all the square units, it's going to be 16 square units, and here is also going to be 9 square units. Now, if you look at this, there is a relationship. This is the longer side. These two are the shorter side. So longest followed by this and this. Now you can see that if you add this, which is 16 to 9, you'll be having 25. Meaning if I add the side 9 plus 6, 16, I should be arriving as what? 25. So that is the relationship. That the shorter side, the two shorter side, if you sum them, you'll be able to get what? The longer side. Don't forget, what we are summing is the area occupied by those sides. The area occupied by this is 16. The area occupied by this length is what? 9. And of the 5 is what? 25. But also in each of them, we can see that they are perfect square. This is 3 square, 4 square, and 5 square. So even though we know 16 plus 9 give us 25, we can also say that 3 square plus 4 square give us what? 5 square. So all that Pythagoras theorem is trying to develop is that the square of the longer side is equals to the sum of the squares of the two shorter sides. Or the sum of the squares of the two shorter sides is equals to the square of the longer side. So that is basically, so you can see this is more or less like creating a staircase. If you want to create a staircase, you have to make it in a way that it is not too steep, whereby people cannot easily climb, and also it is not too low, so that people will find it difficult to move in. So this is what is going to be to any right angle triangle given to you that have the size being given. If I have A, B, C, we know that C square equals to A square plus what? B square. Every right angle triangle, if the side is involved, not the angles, if the side is involved and I'm giving two of the side, I can easily find the third side. So that is the property of Pythagoras. So it states that the sum of the squares of the two shorter side equals to the square of the longer side. And don't forget, the longer side is called hypotenuse. The hypotenuse, whereby the two other sides are also alternating, either the adjacent or the opposite. That can be described if an angle is introduced. If I introduce this angle, then I can call here to be opposite to the angle. Then this is the adjacent to the angle. But if an angle is given to you here, this is going to be the opposite, and this becomes what? The adjacent to the angle. But the longer side always remain hypotenuse. Good. Let's take a question and see how. So for this, we are having two separate right angle triangle that is forming our quadrilateral four-sided figure. Because if I look at this, ABC is a right angle triangle with one of the angle 90. ACD is also right angle triangle. This angle is 90. So I can employ Pythagoras theorem. But the first one is asking for perimeter, meaning add this plus this plus this. But since we don't know this side, what do? We need to be able to find it. If I know this side, I should be able to find this side, because 1, 2, 3 will be used in forming the Pythagoras theorem. So here, so from the triangle ABC, using Pythagoras theorem, if I'm using Pythagoras theorem, I am going to say that the longer side, which is what? The length AC square, is equal to the sum of the squares of the shorter side. You see, this and this are the shorter side. Don't forget that right angle is always facing the hypotenuse, meaning the longer side. So this is going to be AC square equals to 9 plus what? 16. And I believe this can sum up to give us 25. We are not looking for AC squared, but the AC itself, the length of it. So in order to get the square out, we find the square root of both sides. So it means your length AC is going to be the square root of what? 25. And that will be 5 centimeters. Meaning this side is going to be 5 centimeters. I can still use Pythagoras theorem. So from triangle ACD, using the same Pythagoras theorem, we can say that this is the longer side, which is going to be AD square equals to the shorter side 5 square, the longer side, the other shorter side 1, 2, then we have this. So this is going to be AD 25 plus what? I think that will be 144. So your AD squared or AD is going to be the square root of 169, and that will just be 13 centimeter. So this side is going to be 13 centimeter. So in order to find the perimeter, is going to be the addition of all the sides. Don't forget, perimeter is distance around the field. So I'll have the length AB plus BC, which is here, plus CD, then finally we add what? AD. Don't forget, this side is not outside the diagram. It is inside, so we leave it behind. So AD, 3 centimeter, 4 centimeter, and what? 13 centimeter. That will be 25 plus this 29 plus this 32. So we have 32 centimeter. All right. Now the second aspect is asking for area. We know area of the whole of this will be area of this plus the area of this, right? So what do we do? Let's find the area from the first triangle, which will be half base times the height. The base is here, and this is the height. So we are going to have half times 3 centimeter, and that will be, we can have half of 3, so we multiply. That will be 12. Half of 12 is what? 6 centimeter square. Then we come to this. We are also going to have area equals to half times the base times the height. We are taking this, if we shift it up, or we can look at it this way, to call here the base, here the height. The height is always perpendicular. So we are having half times 5 centimeter and 12 centimeter. The height, the base. So this is going to be 60, and half of 60 is what? 30 centimeter. Therefore, area of quadrilateral ABCD is going to be the area of the first, which is 6 centimeters squared, area of the second, which is going to be 30 centimeters squared. And if we add all, we have our 36 centimeter squared as the area of the diagram. Good. I believe you can see that in this we are able to combine the mensuration, finding the area also with the Pythagoras Theorem. All we need to know is the formula, how to find or to relate the longer side with the two shorter sides. I believe you have learned a thing or two from this. If you do and you are new to the channel, please consider subscribing to the channel. Share with your learning colleagues or friends. Like the video and leave a comment so that we get interactive. Bye-bye.